Good morning, dear students, and welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with today's session. Today, we discuss another important law of Newton, which is Newton's third law. So this would be Newton's laws of motion, part 3 of session 4, laws of motion. So until now, we have studied in detail the two different laws of motion, namely the first law of motion called the law of inertia and the second law of motion where we derive the expression for force. But this time we enter into the third law, which is quite interesting one. You will soon see why. So to begin with the third law, we first introduce a concept called impulse. So what is an impulse? Let's take an example of kicking a football, like so the case. Now when you have to kick a football, quite a large amount of force in a small fraction of time. Shall we have a look at that? Where this footballer kicks the football a large force in a short interval of time. And let's observe what happens to the ball. 3, 2, 1. Okay, that was a little fast to catch as well. So let's recap. Let's go back and watch one more time. Here comes the foot kicks. Wow. All right. So a large amount of force on a substance in a short or a small interval of time. So what you observe here is a rapid change in momentum. A ball which was stationary changed its velocity by an applied force which was in a fraction of a second. So this is how we define an impulse. We define an impulse as a large amount of force or a large force acting for a short time to produce a finite change in momentum is called as an impulsive force. So there are other examples of an impulsive force. The other examples is hitting of a tennis ball with a tennis racket. When you smash the tennis ball with a tennis racket, again you're providing a large amount of force in a small fraction of time. Similarly, I want you to come up with more examples where a large force is acting on an object in a small time. So let us try to define this impulse, where impulse is equals to product of force times the time duration. Instead of Instead of writing as force times the time duration, we can also define it by a change in momentum, a rapid change in momentum that occurs. So this is how we define as an impulse. Now that we have learned this impulse, let us try to make a little more analysis about this force that is acting on an object. Now for a footballer who kicks the ball, when he kicks the football, the force is applied to the ball and the ball obviously will displace. But will the footballer experience a reverse force, a return force? It's hard to answer that question. Let's take another example. Instead of a football, I will have a large metal sphere. Okay, we will take a large metal sphere. Now we will ask the footballer to kick that metal sphere. Do you think, anyways, when the footballer kicks the metal sphere, it will displace to a short distance, but will the footballer's leg be intact? No, unfortunately, it might also fracture. But what just happened there? Footballer applied force on the ball. I mean, the force on the metal sphere. How did the metal sphere apply force on a footballer's leg? This is where action for gases that are expelled and a reaction is this rocket moving upward. Both of them occur at the same time, the action as well as the reaction. Next part of the question, how are action and reaction pair related? Now that we know these two action and reaction forces are equal, how are the two related? Now I hope you remember the action of a cannonball and the reaction where it is moving in at a certain inclined, it is inclined at 30 degree of angle. So if that isn't, I'll just mention it here. Okay, this is U, 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 direction forward, backward, forward, downward. So this ball is ball hits the wall at an angle which is of 30 degree, bounces off again at an angle of 30 degree. So the first part of the question, the direction of the force on the wall due to each ball. Direction of force, well, first we have force that is acting along a horizontal direction, which is f of x. By third law, there is also a force which is minus f of x, which is imparted by this wall. So this wall again imparts a force which is of same magnitude minus f of x. Now what about its direction? Well, since it's horizontal, then you can say that there is no angle to it where theta equals to 0. But in this case, a force which is acting at 30 degree of angle. So what happens is when a force is acting of 30 degree of angle, there's an opposing force. Again, here let's say f of xy, since it is tilted, will be negative f of xy for an angle which is theta equals to 30 degree. This wasn't that hard because here we know that the forces are acting on a horizontal, so angle theta is equals to 0. Forces that are acting in an angle at an angle which is of 30 degree, so angle 30 degree. Now for the next part of the question, which is to find the ratio of magnitude of impulse. Ratio of magnitude of impulse. Now I hope you remember in the beginning where we discussed the definition for impulse is nothing but the change in momentum. It can be defined in two various forms. One is a product of force times the time, force times the time duration, and also it can be defined as the change in momentum. So by taking the definition which is change in momentum, we will identify the change in momentum along the x-axis and also along the y-axis. Similarly, change in momentum along the x-axis and the y-axis. So let's start here. M, velocity is u. Okay, one is in a forward direction, which is m times u. Momentum, final momentum along the x-axis, where I've written px of final. Final momentum along the x-axis is minus m times u. Now, why is it minus m times u? Initial momentum is in a forward direction. Final momentum is in the backward direction. Since it is in the opposite direction, it should be negative. Similarly, initial momentum along the y-axis. Do you observe any momentum along the y-axis? No. So therefore, 0. Final momentum along the y-axis, still 0. Change in momentum is defined, change in momentum given by delta p, which is equals to final momentum minus the initial momentum. So we will try to determine the final momentum and the initial momentum for a given, the change in momentum for a given x-axis. Similarly, you can also find change in momentum along the y-axis. Okay, P of y final. So P of x final, which is minus mu minus P of x initial, which is mu. Minus mu is minus 2 mu. And again, change in momentum along the y, P of y, which is equals to 0 minus 0, which is equals to 0. So the change in momentum occurs only along the x-axis. Now, let us have a look at the next. For figure B, change in momentum, to find the change in momentum, you find the initial momentum along the x-axis. So to find the initial momentum along the x-axis, little bit tricky, but not impossible. It is possible here, right? So here's what you do, a little bit of construction. This is anyways 30-degree angle. All right, now m, but minus mu cos theta. Now theta anyways angle we know. How much is the angle? You guessed it right, 30-degree. Now you may wonder, from this you have understood how positive and negative. How is this a positive and negative? Look at the direction. For initial, it is along a positive direction. For final, along the negative direction. Therefore, you have negative mu cos theta. Similarly, we have to find for y. P y initial, which is equals to mu sine 30. Now, is it positive or negative? Have a look at it. The object is moving down. Okay, since it is moving down, down is assigned a negative sign. Up is a positive. So this would be minus. Similarly, Py of final, which is again mu sine theta. This is u sine theta. So the momentum will be minus mu sine theta. Change in momentum, delta along the x-axis, minus mu cos 30 minus mu cos 30, which is equals to minus 2 mu cos 30. Okay. Now for this, delta Py, which is equals to minus mu sine theta minus of minus mu sine theta. And what happens as a sign multiplication, minus into minus? Plus. So you get minus mu sine theta plus mu sine theta, with the two get cancelled, which is equals to 0. So the change in momentum, though it is thrown at a certain angle, the change in momentum occurs only along the x-axis, not along the y-axis. Now, are we done? Almost. Finally, what we have to find is the ratio of magnitude of the impulses. So we already have the value. One is minus 2 mu and the other is minus 2 mu cos theta. Where do I write it? I don't have space. Okay, I'll make use of this space here. I know there are things that are written, but not to worry. So we have to write the ratio. So the ratio will be equals to minus 2 mu divided by minus 2 mu cos theta, isn't it? Yeah. Cos 30. Theta is 30. Cancel, 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 cancel. So what you get is cos 30. Cos 30 is root 3 by 2. So by reciprocal, it becomes 2 by root 3. This is the ratio for the two given objects which are thrown at a different angle, one along the horizontal and other at an inclined 30 degrees. So I think that is all I have for today, a question and with Newton's third law. So in the next session, we will be discussing some of the important conservational laws. Now, there are quite a few conservational laws that you would have learned in primary or the secondary classes. But now we will learn a conservational law which is of momentum. So stay tuned. Visit us at www.we-learning.in to get more details about the classes. There under the playlist, you have a bridge course and also sessions that are based on this Newton laws of motion. So go ahead and take a look at it, share it with your family members, your friends, and students who are in need. So I'll see you on the next session. Until then, take care and have a nice day. Bye-bye.